Remember how we used to think of Zoom as just a web conferencing system? That is, until we discovered we could practically live our entire lives on Zoom. Whether it's taking a yoga class, or in the case of our kids, an actual class, to socializing with friends over drinks, or making music and even art together, Zoom will never be seen the same. Like many everyday things we think of as only being able to do one thing when they can do so much more, the Redis you know and trust for your database cache can also be the only database solution you need, offering the speed, scalability, and advanced data processing capabilities to meet the demands of today's most sophisticated customer-facing applications. When you rediscover Redis, you'll join the world's leading financial services, retail, media, and technology companies that have been using it in ways beyond caching. From supporting high-performance search for financial data, to leveraging geospatial datasets for ride-sharing apps, to building leaderboards for multiplayer games and real-time inventory systems in e-commerce, all relying on Redis for their most important data operations. Your imagination is the only limit to what Redis can do. For whatever challenges you have in your data-intensive application, it's time to rediscover Redis and discover all the possibilities.
Please welcome Redis Lab's co-founder and CEO, Ofer Bengal.
Good morning, good afternoon, good evening, depending on where you are. We are so very happy to host you here, although virtually this time. Normally we do these conferences at the beautiful San Francisco Bay waterfront and have a chance to shake hands, hug old friends, hang out, drink beer together, and have a lot of fun while learning about exciting new capabilities of Redis. However, doing this conference virtually enabled us to host participants from all over the world, from 123 countries to be more precise, including people from the most amazing companies in the world. So first and foremost, I hope you, your family, your circle of loved ones are all safe and sound. In the last few months, we have all learned that working from home has its benefits. Being closer to our families, unless you have little kids, of course, avoiding commute, having more free time, better access to colleagues, customers, service providers, and in general, slowing down the exhausting life and career race and getting back to basics. We at Redis Labs work from home for over 2 months now, and surprise, productivity went up, especially when it comes to developing software. We see a 15 to 20% better productivity. This life cycle is not going to last forever, but I think we all realize that the world has changed and we will probably never return to where we were before pre-COVID. The new normal, according to most predictions, will heavily rely on online services in almost any field or category. Redis has always been an enabler for online services, powering endless number of online applications, which made it extremely popular. Some of these popularity stats are shown here. 5.4 million Redis containers are launched every day on Docker Hub alone, same as MongoDB, MySQL, and Elastic combined. And then in the center here, Redis is the #1 cloud database according to an annual Sumo Logic survey. And talking about surveys, take a look at the right side here. And according to another survey by Hacker News, this one is done among more than 100,000 developers. Redis is the most loved database for a few years in a row. However, many people still consider Redis as a very good caching system, but not as a database. Maybe because in-memory is still perceived not robust enough, or maybe we haven't done a good enough job exposing to the community the enhanced capabilities added to Redis over the years. Whatever the case may be, we hope that during this conference, you will rediscover Redis and its unique capabilities as a database. I refer to capabilities like deploying Redis in active-active Go distribution, where you can write and read locally at the speed of Redis while keeping all databases synced, running Redis on SSD media at the same latencies as on DRAM, the enhanced search capabilities with Redis Search, streaming capabilities with streams, Redis time series, Redis Graph, Redis JSON, Redis AI, and Redis Gears. All these turn Redis from the effective caching layer we all know for years into a powerful primary database. And some of the use cases of Redis as the primary database are super exciting. MoveIt, a company acquired by Intel last week, mobility as a service provider, and a journey planner app. They use Redis as their primary database for over 5 years now to serve 800 million users while managing over 2,000 production databases of Redis containing public transportation data from cities around the globe. And then there is one of the largest credit card issuers. Guys, can you remove all these slides until I tell you? This is really, we don't need any slides until I tell you to continue. Thank you. And then there is, one of the large credit card issuers, I cannot disclose the name, which use Redis as a primary database for their fraud detection and transaction scoring application, as well as in their digital wallet application. This system is deployed globally with active-active Go distribution. If you shop at the Gap website, the checkout process for managing store real-time inventory order fulfillment, as well as delivery locations, run on Redis databases. It leverages the high-throughput Redis search functionality with complex queries and aggregation. A global delivery service company uses Redis as a primary database for delivery route optimization and ground shipment interface suite of applications in support of 7-day delivery and for leveraging ground network for express shipments. This deployment includes several use cases wrapped into one large project based on Redis Search and Redis Graph. And lastly, a leading communications company uses Redis as a primary database to power their 911 service. All calls are directed to Redis, which uses the reference data of the calling number to determine where to direct the call and who should respond to it. This system leverages the active-active Go distribution capabilities of Redis. I truly hope RedisConf will help you rediscover Redis and realize that with so many embedded tools and capabilities, it can serve as your primary database for many of your modern apps and complex use cases, while guaranteeing the best performance under any type of load. Like you, we look for opportunities to innovate. We realized this was the perfect opportunity to rediscover what a digital conference can be. So, guys, immerse yourself in your virtual world, custom built to maximize your learning experience. You can watch live streams, participate in breakout session, network with Redis geeks, personalize their own avatar, and share ideas with community members. We have put together an amazing lineup of the industry leaders across the globe to help you explore the latest innovations and trends in data platforms, including exciting new partner announcements. At your own convenience, you can watch over 50 on-demand sessions to rediscover what you can do with Redis. You also get first-hand access to Redis experts with live one-on-one consultations and live Q&As with session leaders. There is even a hackathon and a special Redis certification cram workshop to help you ace the certification. Lastly, enjoy the networking experience with the biggest Redis community event of the year. When you are not watching sessions, visit the lounge and join conversation on anything from streams to Kubernetes, microservices, and AI, or take a break and play a game of Redis Pong with another Redis geek. Have fun, guys. We are excited to have you here. Let's rediscover Redis together. At this time, it is my pleasure to welcome the creator of Redis, Salvatore Sanfilippo. Salvatore, please.
Thanks, Ofer. Thank you. Hi, everybody. It's cool to be here, even if in this special format. But the time is what it is. Well, today I want to talk about Redis 6, the new version of Redis that was released a couple of days ago. And I want to talk about it just using my terminal. So this is the list of Redis 6 commits, just the description of the commit. And if I sort, let's check how many they are. Okay, 1,000 something. If I sort these commits messages by lexicographically, I can already have many hints about what's new inside this release. So there are ACL, a lot of commits, client-side caching, cluster manager in Redis CLI, expire algorithm modified, many fixes, even a Gopher implementation inside. This is the LCS algorithm, which is basically it's called the longest common subsequence algorithm. It is used often in order to compare genetic sequences, for example, of RNA of viruses, and you can do interesting visualization. For example, I used this new Redis command in order to map the difference between the most related bat virus to SARS-CoV-2 and SARS-CoV-2 itself. And this is the map of differences. The blue part is the basically the genetic information that are the same, the nucleotide that are the same letter, and the red part is the differences. Here, around this area here, where you see this noise, there is the spike protein of the virus, which often changes more rapidly, accumulates more mutations. Basically, the idea is that what happened in the world is too much to don't have any trace inside Redis 6 that was developed during this period. So software is a human factor, and something should remain about all this. Then there is the new lolboot. So every time you see a Redis 6 instance, if you type lolboot, you will see this. Every run is different, right? It's dynamically generated. Now the lolboot of version 6 also can get a version parameter in order to show you the past lolboots. So this is the old one, and this is the current one. So there are many stuff in Redis 6. In the module subsystem, there is a lot of stuff, and also here, replication improvements, precise timeouts, RDB are faster to load. There is a new protocol if you want to use it that is more semantical. It's backward compatible with the past, but if you want, you can use a more semantical protocol in Redis now. Redis benchmark now supports cluster and threads, a lot of things. So the idea is Redis becoming too much complex? Let's do a quick check. How many lines of code we have? Okay, I think we are still small. And what's good is that we have a great deal of comments as well. There are files where basically the number of lines of comment and the line of code are almost the same. But let's check about these new features. So, is ACL a big file? No, it's just the minimum required in order to have a viable system, and still with a lot of comments. Or even more interesting, tracking, which is the new feature of Redis, which implements client-side caching, and I want to talk about this, especially in this 10 minutes that I have, or whatever. Well, tracking is a very small feature. It's just 300 lines of code and a bit more comments. But it could be the most significant feature of Redis 6, perhaps, because it can change a lot of things. So let's check what tracking is. So tracking is basically the server-side support for a protocol that is called client-side caching. The idea is that sometimes there are certain Redis keys that you want to memorize in the client side, because like imagine a social network where a user creates some post. I'm going to the C. Okay. Since this user is very popular, Redis will get a lot of requests to get this key again. However, this kind of information maybe can change from time to time, because the user may edit it. But even if I serve for 100 milliseconds the older version, it's not a big deal. I mean, if I get notified immediately after, I flash the copy that I have in the client side, and that's not a problem. So basically the idea is this key gets requested again and again. What about having a copy of this key inside the application memory? So every client will have a copy of post 1, 2, 3, 4, and when it changes for some reason, there is some notification that I send to all the clients, and the clients will remove this information that they have in memory. This is very important because even if Redis is fast, crossing the network boundaries between the two computers, one thing is to read from the memory of the computer, the other is to read from the fast memory of another computer, but there is the network inside, and this network will cost a lot of things. Will cost latency, will cost the fact that in order to process the I/O, the two computers will have to use a lot of CPU time. So if you think that Redis can in general make your applications faster, you can think at client-side caching as the next step. So part of the working set, the key space more accessed inside Redis can be directly inside your application memory, and that's the point. However, this works as long as you have a very reliable mechanism in order to notify who can have a copy of this key that the key was changed. So normally people did this already with Redis, and when they modify the post, the application modifies the post, what you do is usually to publish in some channel the name of the key. So everybody is listening for this channel with pub/sub, and the key gets removed. However, this protocol has two problems. One is that basically at every set you have to remember to also send a publish. And the publish will also use more bandwidth, more CPU time in the Redis side, and so forth. Moreover, there is another problem, which is in this way there is no selectivity. Basically, maybe you don't have this information cached in certain clients. So the clients that don't have this information maybe don't want to receive the invalidation message. For this reason, Redis 6 introduces this tracking feature that takes care of this kind of things. So let's see how it works. Normally I use a side client a side connection in order to receive the invalidation messages. So let's see what's the idea of this connection. It's 14. So to enable tracking, I just use the client command of Redis, client tracking on redirect to the connection number 14. And when I do that, what happens is that I subscribe here to this channel, and here I should receive the invalidation messages. So for example, if I change post 1, 2, 3, 4, I don't get nothing. But if I request post 1, 2, 3, 4, now Redis believes that I can have a copy because I requested it. And at this point, if the post is modified, now I get an invalidation message. So Redis sent me, please invalidate the copy that you can have of this key. So basically, in the default mode, because there are multiple modes that you can use, client tracking remembers for each client which key, which set of keys it could have memorized. And the way it assumes that the client can have a copy is because it used to fetch this key using a read-only command. However, it is possible to use also an opt-in, opt-out mechanism in order to tell exactly the Redis server what keys we are caching. And also there are parameters that you can tune in order to avoid to use too much memory in order to remember which client has which key. But there is a different mode that you can use with client tracking. So now I disable client tracking, and I now enable it again using a different mode. So tracking on, redirect again to client 14, which is still active. However, I want to receive the notification in broadcast mode. Broadcast means that I don't want the server to track what exact keys I fetched. Just give me every key that changed in the server. I want a notification, but only for certain prefixes. So prefix post and prefix counter. Okay, it was enabled. So now, if any client, including myself, performs an increment in counter 1, 2, 3, I get a notification message about this change. Also, if post is set to a different thing, I get a notification about that. But if an unrelated key is modified, I get nothing here. So basically, client-side tracking can work in two ways. One is very selective, but consumes more memory in the server side and consumes less bandwidth because it avoids sending useless messages. Another mode is where instead we trade server memory, so there is no need to remember which client requested which key. However, we will send more messages. However, thanks to this prefixes trick, we can be somewhat selective. And well, this feature may mean for certain applications to have very big speedups in the fetching of the data. Okay, I want to show another thing, which is the implementation of all this. So, tracking.c. This is the file. It's 300 lines of code. It uses it can be so small because it uses a lot of things that are already inside Redis. The fact that the modification of the keys are already tracked because of watch transaction. You can do watch multi exec, and if something changed, basically in the watched keys, the transaction will file. Maybe you know this feature. So we can build on things that we have. We have radix trees in order to have prefixes and so forth. But what's interesting is the entry points of this code inside the Redis code. So I have here disable tracking and enable tracking, which are called just in the client implementation, in the client command implementation. Disable tracking, okay, and then enable tracking. Here is client tracking off or client tracking on. Here we just do the parsing of the command, and then everything is inside. Then I have tracking remember keys. I want, given my client that's going to execute a command, if I'm not using tracking in broadcasting mode, I want to remember the keys for this client. And if I grep for this one, I find just a single reference inside the server.c, which is here. Basically in the command execution path, in the call function, that is the core of Redis execution of commands. If the command is read-only, and if it's the log caller, let's resolve the real caller of flu itself. And if tracking is enabled but not in broadcasting mode, remember the key. So basically, it's extremely simple of the way this is implemented. And also I need the invalidation part. Tracking invalidate key. And where this API is called, it is just in expire, of course, in db.c, in signal modified key. So this is the API that Redis already had, that is called every time a key is modified, and I handle watch of the transactions here, and now I also handle tracking invalidate keys. So as simple as that. Okay, well, I hope you will enjoy Redis 6. There are so many things: ACL, SSL, IO threading. There is a number of new modules, APIs, and there is a new expire algorithm. A lot of things. But in general, what I want to stress is that Redis is still the simple thing that when you download and compile it, it looks like a toy, but then it can actually solve really interesting problems when the developers apply their creativity in order to use it in the best way. Oh well, just another thing. Because ACLs require to generate passwords for users, and you want this password to be strong, there is a gen password command inside Redis. This gen password works like that. Basically, it uses HMAC SHA 2056 in order to generate random bits, concatenating a seed with a counter. Okay, and the seed is obtained by dev random at startup. And in the latest version, it takes an argument, the number of bits that you want. So basically, you can use this command not just to generate passwords for Redis itself, but every time you need a unique identifier which is not guessable from the outside and which cannot collide if you request one big enough. And since this is not calling dev urandom every run, but it uses basically it in counter mode using the hmac construct. You can abuse this API and generate all the things that you want. This is a very small feature, but I think it's nice, so wanted to talk about this. Okay, so many thanks for watching this session, and now there will be many more. Next one should be Alvin Richards, which is our chief product officer. And have a good conference. Bye.
Thanks, Salvatore. So good morning, good afternoon, good evening, wherever you are on the planet today. Hope you're all well and safe. I've got some great slides to share with you and some great information about products that are launching today and available today. So with much ado, let's move on. So all of you are on your Redis journey. You often use Redis when you're first starting out as a cache. And so what I'm going to talk about is not only the growth of how you use Redis, but how Redis has also grown from Redis 3, 4, 5, and 6 over the last few years. And so we're just here to acknowledge that growth happens, and how you think about Redis and how you think about using it is going to change over time. So let's look at some criteria to use Redis as a database, not just as a cache. And here are just 4 things we're going to talk about this morning: authentication, encryption, global availability, and consistency. These are all key aspects of characteristics that you'd expect for a database. And I'm going to talk about all these things in context of Redis. Now, I'm talking about Redis as a database. And I think there is still an audience out there, and there's a couple of people still to convince. Charity I've known for years through other companies and other events in community, and she's has a very vocal opinion, and I think her opinion is shared by many others. And part of what we're trying to do is to show you how Redis has evolved and changed over time. And perhaps it's now time to think of Redis as a database. So let's talk about the first thing we want to announce today. So as Salvatore has released open source Redis, what we want to announce today is the availability of not only just Redis open source, but Redis Enterprise. So you can go download it, you can use it, you can give us our feedback, and you can tell us all the great things that you love in it and all the things that you want next. Let's have a sort of quick look at what those major features are. In open source, Salvatore's talked about access control lists. And so this is a very important step on the journey to make Redis a robust and reliable database. There's many other things that also changed, improved in open source 6. There's improved elections. There's a new threaded I/O. And as you saw, there's a demonstration just now for the REST 3 protocol. These are great features that are being added into the open source project to extend its capability. Layered on top of that is Redis Enterprise. And so we've been actively working to add in those additional functionalities that enterprises are craving for. And so we've taken access control lists and we're adding a layer above that to do role-based access control. And so this just allows simplified administration at scale. We've also been extending our active technology to incorporate hyperlog login streams. And so we're going to talk about a couple of these things as we go through these slides. So let's first talk about why does access control list matter? Well, the key thing that's been introduced is the ability to specify for a given set of keys what operations can be performed. So in this first example you see here, we have Alice. There's a regex expression for the keys that they can match, tilde, cache, colon, star, and then the operation that can perform. So this allows for a strict separation of concerns between what the application or a service might need to access and what commands the administrator will need to access in order to maintain the Redis cluster. So you can now separate these groups apart. What this means is that you've got a far reduced attack surface. You no longer have a single user that you're authenticating against. You can now set up all the different users and roles as required to meet any compliance or regulatory needs that you have. My favorite part of ACLs is, and I've done this plenty of times, is remove the ability to run flush DB, i.e. clear out the entire cache. So, automatically removing myself the privilege to run that command is saving me a lot of fat fingering. So if that's ACLs, how do they look and how do they compare to role-based access control? So you see on the left here, we can set up each individual with particular permissions on keys and commands. And so that is really great in a development and test environment. It allows a very simple way to administer and set up all of those rules. But when you start to get at scale at a larger enterprise, role-based access control allows you to define the role once with those permissions and then assign users to that role. That means that you can change the role definition and all users now conform to that, rather than having to go through user by user by user. So that greatly reduces the administration burden in day two operations. So we think it's a really great set of features, but it's just the first sort of step on the path for the Redis 6 family. What are we working on next? Well, now that we've got role-based access control, many people will want to configure them through external identity providers, so Active Directory or LDAP. So the next step is to be able to configure those roles not just within a Redis Enterprise cluster, but from outside the Redis Enterprise cluster. Again, this simplifies the administration burden. We're adding TLS 1.3 support, so we're getting the latest ciphers, the latest version. We're also adding mutual TLS authentication, so you only need the certificate chain only. And then we're extending active support to support search. And if you're not familiar with Redis Search, this is an extension to core Redis that allows you to do full text search, doing stemming, stop words, and all the other great fuzzy matching and text searching that you can do. So these are sort of some really great things that we're working towards in Redis 6. So what are the next steps? You download the software. You can use it on the cloud right now and go for a free tier service just to go try it out. There's a couple of great sessions in the conference today and tomorrow. And so there's a security best practices by one of our product managers. There's also a great talk by Apple about how they're using these features in Redis 6. So if you've got an interest in this area, I'd love for you to go and check those out. So that's the first thing I wanted to talk about today. What's the second thing? Well, encryption in use. So encryption in general is a very well-known thing that you want to do. But what about encryption when you're using the data? So let's first think about what is the state of encryption in Redis today, right? So you've got encryption at rest. You can use encrypted disks or encrypted volumes so that that data when it's at rest is stored in an encrypted way, which means that if that volume is compromised, then the data is not usable because you don't need the keys. Encryption in transit, well, we've got TLS support. So that means that the traffic going in and out of the cluster is all encrypted. But what about that data that's in use, that key value? And so the way that most people kind of start to think about encrypting the data in use is by encrypting it at the application. So we have a very simple example here where we are taking the value 33. We are going to encrypt that value with OpenSSL. We get this big, long gobbledygook string. And then in the Redis CLI, I can now set my key with that gobbledygook string. This is great. The application has encrypted the data. It's passed it to Redis to store it. And Redis is now storing that encrypted value. Well, the downside of doing application-level encryption is that you can no longer perform certain database operations. So if you look at this next command, we'd now try to increment that value by 1. But that value is not a plain 33, it is a binary string. And so Redis return that it can't increment that value. So by doing application-level encryption, it means that whilst your data is secure in use, you're not allowing the database to perform operations against some of that data. So what we're super excited to announce today is a combination of 3 pieces of technology. Secure enclaves from Anjuna, plus Redis, plus secure Microsoft compute from Azure. So these technologies combined allow you to solve this problem in a very interesting and unique way. So let me kind of dive into that a little bit more. So Anjuna provides what they would describe as an enterprise enclave. Now, this is all based on the fundamental work that Intel, AMD, and ARM have been doing to introduce new instructions and new capabilities in their chipset to allow essentially a process space to be secure to a single process. So up at the top, we see Redis. An enclave is created around it, so its network storage and memory are essentially private to that process. And what that means that from the outside of that enclave, everything looks encrypted, but to the inside of the enclave, that process sees that data in plain text as it would do it normally. So why is that important? Well, a couple of critical things. First, it means that data in memory is now protected. It's now encrypted. So if I do a core dump or a dump core of that process or do inspect the memory, all I see is encrypted data. I no longer see that plain text data. But it also means that because the process inside that enclave can see the unencrypted data, all of the database operations are still possible. I can now still do my increment on what the outside world thinks is an encrypted value, but on the inside is a plain value that those operations can now perform. And this is kind of critical because what this means is you don't have to change any of your application code in order to take advantage of the data now being encrypted in use. So how is this all done? Well, Anjuna are providing the technology to wrap this up. As I said, it's using the base capabilities of the CPU from AMD, Intel, and ARM. On top of that, you've got the operating system, the containers, and the virtualization. And the final part of the deployment is its availability in numerous cloud vendors. So in terms of the CPUs, every CPU shipped in 2021 is going to have this capability, and the cloud vendors are slowly rolling out this capability. And Microsoft Azure Secure Compute is one of the first ones out there. So we're super excited about that. What are the kind of next steps for in-memory encryption? Well, obviously try it. It's available as an open source image on the Azure Marketplace to date. So go have a play with it. We're currently working on the validation to validate the technology with Redis Enterprise. And we're performing some initial performance benchmarks because, as we all know, encryption is not free. What we want to understand is the performance implication to various workloads and what that means. There is a talk in the conference that if you want to find out more, that's been presented by Redis Labs, Anjuna, and Intel. So lots of really great content. So that's the second thing. What's the third thing I want to talk about? So again, this is available today. We are announcing the availability of streams plus active-active. So what does that all mean? Streams, if you're unfamiliar with in Redis, have been available since Redis 5. They've been very, very popular since Redis 5 first came out. And essentially, they're log structured append-only data model. Now, Redis has had a traditional pub/sub mechanism for many, many years. But you would only get those messages delivered if your client was connected when the message was pushed. What streams do is they add the restartability. So it means that from reading a stream's perspective, you can reconnect at any point and start your window or a point in that stream where you want to carry on reading from. So this is great in terms of the reliability, but also the additional things that streams provide is consumer groups. So I can now subset this stream by processing by different clients and making this a very scalable solution that is very reliable because of the restartability. So that's streams. What about active-active? So active-active, again, is a technology that's been available in Redis Enterprise for many years. But what it is intended to do is provide geo-replication between Redis clusters across availability zones, data centers, or even geographical regions. And the mechanism behind how this works is CRDTs, or conflict-free replicated data types. So this allows Redis to have automatic ways to resolve conflicts when two different clusters have performed writes against the same key. Because the inherent nature of Redis with its data structures and the operations it can perform against those data structures, it means that there is many different strategies can be employed by data type and by operation. And this allows for a very sophisticated approach to how those conflicts can be resolved. The great thing from a developer's perspective is that you get very low latency on those local writes. So you get all the characteristics of Redis you'd expect. Those low latency writes are then propagated to the other clusters, and they will eventually coalesce to a single value. So what does it look like if we combine these two technologies together? Well, this is a bit sort of complicated to follow, but let me try and walk you through it. So we have two clients, client 1, client 2. These can be in two separate clusters that are linked together with active-active. So we see on step 1, an add to that stream takes place, and a read can occur, and you can see that value that's being added. If you now look at step 2 on client 2, reading that group means the entry is not visible because those changes have not been synchronized across the clusters. So we see at step 3, the synchronization is completed, and therefore the replication is completed. On client 1, we can acknowledge that we've processed that event, that entry, and if we now look at the stream again, it's empty. If we look at step 6, we can now see that on the second client, if I now do a read, because those changes have been synchronized, I can now see that value. And if we now go on to step 7, that after another synchronization has occurred, it means that that acknowledgement of that message by client 1 has now been synchronized. So when you go to read the group again, that entry is no longer visible. right? So you've now created an application where you can process these streams in a globally distributed way, but ensuring that you're always getting a consistent view of those streams, irregardless of which cluster you are reading from. We think this is absolutely going to be awesome. So what are the next steps? Well, obviously, you can download it and try it. There's a couple of great talks by Redis Labs, but there's also talk about by Uber about how they use this active-active with streams to solve many use cases in their environment. So that's the third awesome thing that we're announcing today. Now, the final thing I want to talk about, I am really excited about a project that's been going on for many years internally within Redis and Redis Labs, which is all about how to think about data consistency in Redis. So what we are, if we think about consistency in Redis today, is Redis is inherently an AP system. Right, so it's going to choose availability over consistency because it's a distributed system, so it has to do partition tolerance. Now, with active-active, as we just talked about, you get strong but eventual consistency. So there may be some propagation delay between particular clusters between that data to be available. And strong eventual consistency solves many problems. But what we're excited to announce today is sometime early this summer, we're going to be open sourcing a new module to Redis called Redis Raft. And what this supports is strong consistency. And so this now opens up a whole new set of use cases where you're guaranteed the data consistency irregardless of where you're reading from within that cluster. We think this is going to be very exciting. So let me give you a little bit of context. So we're basing this on Raft. And Raft is a very popular consensus-based algorithm for replicating state across many machines. There's a bunch of implementations, and it's used widely by things like etcd, console, MongoDB, a bunch of other database products. There are other consensus algorithms, like you may have heard of Paxos, and Paxos is another typical one that's used to solve this problem. So if that's Raft, what is Redis plus Raft? Well, what this gives us is the ability to offer strong consistency for a cluster of Redis servers. The Redis Raft module itself is responsible for things like leader elections, replication, persistence. And as we go on, we're adding more capabilities so that will allow for things like dynamic cluster membership, being able to manage the resources to support this consistency, as well as adding things like performance and tuning knobs so that you can optimize your deployment for your particular use case in the most effective way. What are the next steps? So when we open source this early in the summer, please download it and try it out. Give us your feedback. It's not ready for production, right? So we're still working on it. We're still validating it. And so please don't put this into production. We're doing a whole bunch of testing, and there's a great talk later today, but we're doing some initial Jepsen testing is complete. Obviously, we're finding issues, we're correcting those issues, we're retesting. And as the year progresses, we'll be extending the Jepsen testing to Redis Enterprise, so we'll make this not only available for open source users, but also for enterprise users. If you want to know more about the state of where we are in the development and the technology behind it and how we've been doing the testing, there's a great talk at the conference by Yossi, who's one of our chief architects, and Carl Kinsbury, who's the man behind all the Jepsen testing. So great things. So super excited about that. So just to wrap up and conclude, it's time to stop thinking of Redis as just as a cache. right? Redis is growing up just in the same way that the use cases you have built using Redis and how Redis has changed with additional data structures and access control lists is changing and growing as well. Growth happens, and Redis Enterprise now gives you a way to get some of this extended functionality in order to extend these sort of use cases. So that's all I've got for you this morning. There's a bunch of awesome, great things that I would love for you to try out, give us feedback, and I hope the conference gives you a lot of great information to continue your journey with Redis. So at this point, I want to thank you, and I would like to introduce to our virtual stage Yiftach Shoolman.
Hi everyone, I am Yiftach Shoolman, CTO and co-founder at Redis Labs, and my talk today is all about doing more with data. First thing our customers are telling us they do before they start any data-related project is making sure their current infrastructure is fully optimized. And optimization should start with the basic ingredient of computer hardware, the chipset memory. If just a year ago you should have used two different types of memories in order to store your real-time data, DRAM for your hot object and SSD for your warm object, nowadays you can put everything in a single persistent memory chipset. Moving up a bit in the stack, many of our customers have already started a consolidation process in which they consolidate their caching and database system into a single in-memory database. This way they have a much faster access to their data because they don't need to deal with cache misses event in which the objects do not exist in the cache anymore and need to be retrieved from the database. This is also a more reliable and simpler solution because you only need to manage one system. Many of the analysts we are talking with today have already started to put their analyst tool on the top of operational database. Why should someone ETL his data to another system and then wait hours and sometimes days to see the result if there is a simple way to see everything while they're happening? And of course, data silos doesn't make sense anymore. Imagine that for a single transaction that need to process multiple data types, you should have deployed between 5 to 10 different data services. This is expensive, complex, even if everything is provided to you as a fully managed service, and extremely, extremely slow. Many of the developers that we have talked with have already started to design their application with native data types and models, and get rid of the tons of abstraction layers that slow down their application performance. If you go to dbengine.com, you can see that the trend of developing or modeling with graph, document, time series, key value, and search is soaring, while modeling with relational database stays flat and even declines. There are many databases today that offer a multi-model capabilities, but most of them do it at the API level only. And behind the scene, what is running is an old engine that was not designed to deal with all these data models. This provides only a portion of the functionality and cannot be scaled in production. Alternatively, there are some databases out there that were designed from the ground up to support multiple data models, each with a dedicated engine. If you choose to use that architecture, you can end up with only a single database for all your real-time needs, and for your non-real-time needs, you can use other databases. Last, doing more with data also means that it's about time to take AI to production. Analysts estimated that by 2020 or 2021, the revenue associated with AI inferencing will increase the revenue associated with AI training, and from that moment on, the gap will only increase. This is because people realize that training a model is a complex thing to do. You need to have access to a lot of data and then experiment with your model for months and sometimes for years. Alternatively, there are many already baked AI models out there that you can tweak for your own use cases. For instance, by using your own reference data with these models and taking them to production in a much faster manner. And finally, if you want to orchestrate every flow in this new data architecture, you need to have a fully programmable serverless engine that runs in a fully distributed manner, closer to where your data live, preferably inside the database. And this is exactly why Redis needs serverless. Redis needs serverless in order to do cluster-wide data processing across data structure and modules, to be able to do reliable event processing, and to orchestrate your AI transaction. And you want all this to be done at the Redis speed, at a millisecond. So a year ago, we announced a very nice project called Redis Gears. Redis Gear is a serverless engine for infinite programmability option in Redis. Today, I am happy to announce that Redis Gear is generally available. Let me show you how Redis Gears works. Redis Gears completely abstract the Redis deployment from your code. You write your code once and deploy it over a single instance of Redis, Redis cluster, and even Redis Enterprise cluster. Redis Gears allows you to do operation across data structure and modules. It supports event-driven transaction and batch operation. And you can write your Gear function in Python, C, and very soon other languages like Java and Scala, Rust, and C++. Behind the scene, what is running is a completely robust architecture written in C and deploying in a fully distributed manner across all the shards of your cluster. Let's see how Redis Gears can help you solving a real production problem. And in this specific example, let's see how Redis can be used as a front-end database in front other databases and use Redis Gears to do write-behind operations. In this case, your application will read and write from Redis only, and Redis will asynchronously update your other databases. So let's see how it works. Let's assume that your application is write something to Redis. In this case, it changes something in a hash. You will write the first Gear function that will trigger by the keyspace notification and write the changes into a stream. And only then Redis will acknowledge the application server to avoid the situations that if something bad happens, you will lose your rights. And then you write another Gear function that asynchronously take the changes from the stream and write it to a backend system. For the general availability of Redis Gears, we support 5 different types of backends: MySQL, SQL, Oracle, Cassandra, and even Snowflake. Let's see how all this runs in productions. One of our customers wanted to improve his application performance that was based on MySQL and decided to deploy Redis with write behind. Unsurprisingly, once Redis was deployed, the performance of the application jumped by 3 to 4 times. But what is practically more interesting is to understand what was running behind the scene. As you can see on the top right, Redis buffers the write request, avoiding MySQL to reach to a saturated point. But in addition to that, it grouped together the write request and batched them to MySQL. By doing so, it practically improved the MySQL performance. And accordingly, the performance of the application or the latency of the application reduces significantly by 70 to 90%. Now let's see how easy it is to run real-time data processing with Redis Gears. In this specific scenario, we created a cluster and populated it with profiles. Each profile includes the username and the age of the user. And we wanted to run an aggregated function on the top of clusters that calculated the maximum age of our populations. You all know that if you wanted to do it without Redis Gears, you should have written an application that runs outside Redis, access every shard separately. That means this application needs to know the IP address and the port of each shard, scans all the keys, and do the aggregation. Now today, with Redis Gears, powered by Redis Insight, you can do everything very easily. Redis Insight is a great tool to analyze and monitor everything that runs inside Redis. And today, it also includes a way to write Gear functions and deploy them on every Redis deployment. So let's run the demo. We created a 3-node cluster setup and populated the cluster with the user profiles. User profiles are built on the top of Redis Hash and include the name and the age of each user. And then we run the Gear functions directly taking from the Gears documentations. The first function does local max calculations. That means it is mapped to each shard of the cluster and calculate the max age of the profiles across every shard. As you can see here, the 3 values. The next function does exactly the same, but it does it in a cluster-wide operation. It first calculates the local maximum and then aggregate everything to a single value. And this is how easy it is to create any real-time data processing with Redis gears, powered by Redis Insight on any Redis deployment. So we showed how easy it is to do cluster-wide operation with Redis gears, operation between data structures and modules, and even reliable event processing like shown in the right behind example. Now let's see how we can orchestrate AI transaction with Redis gears. And in this specific example, we try to predict the lifetime of COVID-19. This is based on a research done by the US government that shows that in certain weather conditions, like 75 degree Fahrenheit and 80% humidity and summer sunlight, the half-life of the coronavirus can be as minimum as 2 minutes. That means if you put a group of viruses on a certain surface, after 2 minutes, half of them will be killed. After 4 minutes, another half of them will be killed. So in this specific weather condition, the chances for the pandemic to be completely vanished are very, very high. So we decided to see where and when this can happen. We took the weather conditions or the weather metrics from Brooklyn, because this is where everything started in the US, and populate the Redis time series with this data. And then we ran Prophet. Prophet is an open source project created by Facebook that does prediction over time series data. Prophet is written in Python, and therefore it was very easy for us to integrate it with Redis gears. And let's see how it works. We will use again the Redis Insight to monitor what is going on in this experiment. The first thing we do, we populate a Redis time series with the temperature of Brooklyn since 2014. Then we will run Prophet to do a prediction. Prophet is run very close to the time series data in the same memory space and create the prediction in a very fast manner, like less than 20 seconds. You can see that the prediction includes 3 different time series for high, low, and average temperature of next year. And then we populated another Redis time series with the humidity parameter of Brooklyn, again, from 2014 until nowadays. We will run Prophet again to create the humidity prediction. As before, the prediction came in a relatively fast manner. In this case, there is only a single line of prediction. Now let's see the point in which the humidity reached to around 80% and the temperature is around 75 degrees Fahrenheit. You can see that this is practically the mid of May, which is practically nowadays. So first of all, this is good news for the people who live in New York. And secondly, let's see what Prophet does and what Redis gears does in this experiment. Prophet does all the prediction. Redis gears makes sure that the prediction is running very close to where the data is stored in Redis time series. And whenever Prophet generate predictions, Redis gears insert those predictions into different time series. This is how powerful Redis gears is. You can do things like write behind, real-time data processing, and even orchestrate your AI transaction. Empowering existing model is only one thing that you can do with AI. But Redis can be used to much more than that. Redis can practically be used as your AI serving platform. If we look at typical AI lifecycle, it includes a preparation phase, a training phase, and usually what you do then, you take, once you believe that your model is ready, you take the model to production. This is where AI serving takes place. It includes deploying the model, running the inferencing, and do performance monitoring. And there are a couple of challenges including in the AI serving platform. First of all, you want to make sure that the end-to-end inferencing is fast. And we found that in many cases, the time it takes to collect the data and process it before you feed it to AI is much more than the inferencing itself. So even if you improve your inferencing engine by an order of magnitude because there is a new chipset in the market, it doesn't really affect the end-to-end inferencing time. Of course, your AI serving platform should be highly available and scalable. It should work with state-of-the-art tools like MLflow and Kubeflow, and it should support multiple types of backends like PyTorch, TensorFlow, and even the traditional linear regression or random forest ML models. Performance monitoring is of course important because you would like to fix your model over time. Last but not least, you would like to be able to deploy your AI engine everywhere. You probably decide to train it in the cloud, but you would like to deploy it in different cloud, on-prem, on the edge, and even in small Raspberry Pi devices. This is why we created Redis AI. Redis AI is an AI serving platform that runs inside Redis. It includes tensors. This is a new data type that holds the neural network information. It supports all the popular backend systems, TensorFlow, PyTorch, Onyx Runtime, and it's fully integrated with MLflow. Redis AI is based on the robust architecture of Redis. It is highly available and scalable. It can run on a CPU or a GPU. It will very soon support monitoring and A/B testing capabilities. And maybe the most important, Redis AI runs very, very close to where your reference data is, and therefore can perform the inferencing much faster. Like Redis AI can be deployed everywhere or anywhere, cloud, on-prem, edge, and Raspberry Pi devices. And today, I'm happy to announce that Redis AI is generally available. Please note that Redis AI is a cooperation between Redis Labs and TensorWorks. TensorWorks is a company that specializes in building AI models. How fast is Redis AI? We compare two setups, one in which the AI serving is deployed far from the data, and one in which the AI serving is deployed close to the data with Redis AI. And we use the traditional transaction scoring example because it shows very nicely where the problem is. In transaction scoring, the user issues a transaction, it arrives to the application server, and then the application needs to fetch multiple profiles, usually from one or two different databases. Profiles include the user profile, the margin profile, and probably the location profiles. Then the application server needs to combine this profile together with the transactions, vectorize everything, send it to the AI engine, and reply back to the user, pass or fail. The same goes with Redis AI, but in this case, the application server needs to do only a single transaction with the transaction data and the pointer to the reference data that located inside Redis. So we decided to test this benchmark and to see the differences between two. For that, we created a very nice benchmarking tool called AI Bench. AI Bench is an open source project for benchmarking AI serving engine. On the left side, when we tested the serving AI far from the data, we compare Redis AI to TensorFlow serving, TorchServe, and JUnicorn, which is a common HTTP server. Please note that even if we serve the AI, even in the case that we serve AI far from the data, we use Redis to host the reference data because we thought it's a much more balanced comparison. But you should know that if we were using other databases, the entire performance of the left setup would have been very, very slow. And in both cases, we use the Kaggle credit card fraud detections as a model. And this is what we found. Although all the serving engine use the same backend, TensorFlow or PyTorch, Redis AI outperform all the other serving engine by a factor of 4 to 9. There are two main reasons for that. First, Redis AI runs closer to where the data lives, and therefore the overhead associated with bringing the data is reduced significantly. And secondly, we found that the shared nothing architecture of Redis is much more scalable than the multi-threaded architecture of the other serving engines. When we look at the latency, we found similar results. Please note that in all tests, Redis AI was performing under sub-millisecond latency. And when we combine the two, you can see that Redis AI outperformed all the other AI serving engines by an order to 2 orders of magnitude. I think this is very impressive. So we have just announced the general availability of Redis Gears and Redis AI that we believe are going to be an important part of the Redis future. And you may ask yourself, where do we take Redis from here? So we'll continue to invest in Redis as the best caching engine in the market. We just added two important capabilities, client-side caching to Redis 6.0, and write behind and write through using the combination of Redis Gears and Redis. We'll continue to improve existing data models in Redis and add new if needed, and make sure that whatever you run at the top of Redis, you will get the fastest performance in the market. And with the addition of Redis Gears and Redis AI, Redis is becoming more than a database. You can use Redis as your real-time data platform for existing and next-generation cognitive application. Thank you very much. I hope this session was informative. Please note that there are dedicated sessions for Redis Gears and Redis AI that you can get more details about this technology. And let me call to the stage my friend and co-founder, Ofer Bengal.
Thanks, Yiftach. We constantly work to make Redis available anywhere and everywhere, and to feature its enhanced capabilities and top performance wherever it is deployed. As part of this, we work with cloud providers to enhance their managed Redis services. And today, I am very proud to announce a new partnership between Microsoft and Redis Labs to offer Redis Enterprise as a new top tier of the Azure Cache for Redis service. Teams from the two companies are jointly working on building this amazing solution for a few months now, and we will bring it to market very soon. The driving force behind this partnership was an amazing lady with whom I had the privilege to work in the last few months. Her name is Julia Liuson, and she's the corporate vice president of the Microsoft Developer Division. Julia has honored us by joining this conference today to talk about our partnership. Julia, please.
Thank you, Ofer. It's a real honor to be here. I lead Developer Division at Microsoft. My team's mission is to build the tools and services that developers love and use every day. And we want to empower every developer and every development team on the planet to build more applications. And the core of our mission is Azure. And I think that I'm hoping the slide will be showing up soon. Thank you. And this map shows you all of our Azure regions around the world. We have more regions deployed than AWS and Google combined. We will continue to build out in more countries and support more data sovereignty regions. Our global footprint means that you can run your business pretty much everywhere around the world. Now, we have also continued to build out security, compliance, and trust. If you cut over to the video, you will see on the slide that we have over 91 certifications issued from standards organization, as well as various governments. We are continuing to lead all cloud providers in terms of the number of certifications we have. We want to give you the confidence that you can run your business, not just anywhere in the world, but also with the compliance and certifications that you need and the trust that you depend on. Now, with that, we feel very fortunate to have over 95% of Fortune 5 companies building on top of our cloud platform. You can see it's an amazing selection of companies that really span all industries. And I hope some of you are on the call here today. And not only is Azure an amazing platform for your application, we are also committed to building the most developer-friendly cloud, bring developer tools that you love for development, productivity, and collaboration. We have seen unprecedented growth and usage of Visual Studio and Visual Studio Code in the last few years. And today we have more than 20 million monthly active users using our family of tools. And in 2018, Microsoft completed the acquisition of GitHub, which is the largest developer community on the planet, with over 44 million registered users that use GitHub to collaborate with each other. Last year, developers made over 1 billion contributions to the open source projects and the private repos that are hosted on GitHub. Today, 99% of all new software projects in the world will use open source, and GitHub is the home of open source development. With GitHub, we're trying to automate the process so that you can go from code to cloud in a seamless way, whether you're developing open source software or enterprise solutions. Because of open source software is so critical to the success of every software project, this is why that we have been working super hard to contribute and partner in the open source ecosystem. Visual Studio Code, TypeScript, .NET Core, Kubernetes are just some examples of top open source projects that we have been contributing to. We have been working hard to partner with open source technology providers to create more value for the entire ecosystem and for our customers. Here are just a few examples that we're showing. We work very closely with HashiCorp to build out HashiCorp Console service on Azure. It enables Azure customers to natively provision HashiCorp managed console cluster in any Azure region directly from our Azure marketplace. We have also worked very closely with VMware Pivotal to jointly engineer and support Azure Spring Cloud. This allows Java developers to easily build and deliver Java Spring applications in a fully managed microservice development platform. Through our partnership, we want to make it easy for customers to acquire and use open source technologies directly in Azure and deliver deep integration around identity, security, and unified billing. This will significantly increase both operational efficiency and developer productivity for our customers. We believe this approach is a big win for our customers and partners. So we're super excited to be forming this new partnership with Redis Labs and to continue to demonstrate our commitment to open source companies. We have seen incredible growth and enthusiasm from our developer base over the past few years with our existing Azure Cache for Redis offer. This is a fully managed service that was built 7 years ago and delivers a version of the popular open source Redis in a turnkey solution. Today, building on top of this, we'll be adding 2 new enterprise tiers. The enterprise SKU will be an in-memory offer using Redis Lab Enterprise. The enterprise SSD tier will be built on top of the Redis on Flash technology and deliver up to 10 times larger cache sizes and similar performance at a lower price per gigabyte. By co-developing with Redis Lab team, we're thrilled to bring its new Redis Enterprise technology directly into Azure. Together, we can provide a native Redis Lab experience that is more productive, more secure, compliant, and resilient, and is very easy to administer in Azure. The new Azure Redis Enterprise provides significantly improved developer productivity. Developers can easily use latest version of Redis and use all of its native data structures and modules for capabilities like Redis Bloom, Redis Time Series, or Redis Search. And developers can also deploy a Redis cluster within minutes to scale without additional steps of sizing or provisioning VMs. For developers who are already familiar with the current Azure Cache for Redis, the new enterprise tier will have the same interface and management experience, enabling developers to start immediately with the service. Now, Redis is frequently used in mission-critical applications, so greater resiliency, security, and compliance is a must-have for the service. We will deliver enterprise-grade SLAs, offering additional uptime through Redis Enterprise Active Geo-replication technology across Azure regions. And with this joint partnership, the enterprise tier will support all of the most stringent requirements on security and compliance that is demanded by our most security-minded customers. Will absolutely fulfill the security and compliance requirement. And this service will deliver a simplified administration and billing experience. All of the native Azure management experience will just work, like ARM templates, command line interfaces, and our Terraform support. Customers can seal Redis cache size real time based on their need. This provides potentially cost savings in our consumption-based pricing model. Now, Redis Enterprise usage will simply show up in customers' monthly Azure bill. And working together, we will also deliver a simplified and streamlined support experience. Customer with issues will simply call Microsoft first for any service issues, and then we will pull in Redis Lab as needed on software-related questions. With that, I'd like to welcome Balin to show a demo of this technology in Azure.
Hello everybody, I'm Balin Subramanian. I'm the Director of Product for Azure Developer Services at Microsoft, and I'm really excited to be here today at RedisConf. As Julia mentioned, we've seamlessly integrated Redis Enterprise into Azure Cache for Redis, a secure, scalable, fully managed service available in all Azure regions worldwide. Today I want to show you how easy it is to get started with Redis Enterprise on Azure and start using advanced Redis capabilities in your applications. The application that we'll use today is Brew Redis, an inventory management system for beer. I've already deployed this Java Spring application to Azure Spring Cloud, a fully managed platform service for Java microservices that we announced jointly with VMware at Spring 1 last year. All this application needs now is advanced Redis capabilities such as modules and geo-replication to provide a modern cloud-scale experience for beer shopping. Let's start with creating a new cache instance in the Azure portal. Now we can see all the available cache types, including the enterprise tier that we are announcing today. This tier enables advanced Redis Enterprise capabilities, including Redis modules, Redis on Flash, and active geo-replication. Let's start with the Enterprise E2 cache, which is a 12 GB cache with replication and automatic failover. Now we can configure advanced capabilities such as modules. Here are some of the modules that are available out of the box. Our application is going to need some search functionality, so let's pick the Redis search module. Typically, when you want to use partner services on Azure, you would get it from the Azure Marketplace and independently provision and configure it. But we work closely with Redis Labs to make the integration seamless, all the way from how you get Redis Enterprise to how you pay for it and get support for it. We're also working on making it easy for Azure customers to use their existing credits and enterprise agreements with Redis Enterprise. While Azure operates the service globally, you're directly engaged with Redis Labs and their fantastic expertise on Redis. It's the best of Azure and Redis in one service. While the deployment is underway, I want to show you how easy it is to work with Redis Enterprise, just like with any other first-class Azure service. Now you can use Azure Resource Manager templates to set up fully managed Redis Enterprise along with the rest of your infrastructure on Azure. You can also use the Azure CLI and Terraform to create and manage your cache instances on Azure. The deployment takes a few minutes to complete, so let's go ahead and use a cache that I've already created. This is a Redis Enterprise cache, and it has the search module enabled. You can use capabilities such as Azure RBAC to manage access to this cache, and you also get out-of-the-box monitoring and alerting through Azure Monitor. Because Redis Enterprise is now part of a first-class Azure service, we can easily integrate it into our application using native bindings such as the ones provided by the Spring Cloud service. Let's go ahead and create a service binding. As you can see, with service bindings, there are no connection strings to remember, and key management is automatic. You can also use this cache with other tools available in the Redis ecosystem. To do that, typically you need an access key, and that's easy to get from the Azure portal or through the Azure CLI. For example, you can use the Redis Insight tool together with this Redis Enterprise cache on Azure. You can use the same modules to search and query your cache, and you also get to use tools such as the memory analyzer to get recommendations on optimizing your cache. Let's go back to our application and see what beer we have available for us on Azure. Not only that, we can now search for our favorite beer. That logger looks good just about now, and looks like there's actually some available right around the corner. The integration extends beyond resource provisioning and management to monitoring and using Redis Enterprise with other Azure services. With this integration, we brought the best of Redis Enterprise into Azure, the cloud platform for developers. Together with Redis Labs, we are looking forward to all the ways developers will build cloud-scale applications using Redis. Thank you.
Great. So today, we are announcing a preview of the enterprise tier. And would you please show slide, please? As you saw in the demo earlier, it already supports Redis modules, Redis on Flash, and a very first-class Azure user experience. We're working hard to deliver a public preview this fall with integrated billing, adopting newer versions of Redis along the way, and we expect to reach general availability by winter, where you will benefit from enhanced SLAs. With each release, we'll be working to add capabilities that address your feedback and further improve productivity, cost effectiveness, migration capabilities, resiliency, and security. We are so excited to be joining force with Redis Lab, the home of open source Redis, and host Redis Lab natively on Azure. Together, we'll deliver the most innovative Redis solution on the most broadly available, secure, and trusted enterprise cloud. Thank you so much for this partnership, and happy coding. Back to you, Ofer.
Thank you very much, Julia. This was really fascinating, and we are super excited with this partnership. People are building amazing apps with Redis, and some of them are very inspiring. Before we close this morning's session, I would like to tell you about one such app built rapidly around Redis to solve urgent needs relating to COVID-19. It is called COVID-19 Mission Control, and it was built by MD Metrics. It enables hospitals and countries manage all the data concerning COVID-19 patients, their age, hospitalization details, all their symptoms, all treatments they received, and show all that in a very clear and easy to understand dashboard. But the main benefit of this app, built entirely around Redis Graph and Redis Search, is its complex querying capabilities, enabling queries such as show me all patients with asthma treated with a ventilator and receiving medications that prove to be effective. I urge you to take a look at mdmetrics.com. That's metrics with X at the end. In the coming sessions, you will be able to learn about many more interesting use cases for Redis and how Redis can become a primary database in your apps. We have prepared a very rich program for you, so please make sure to take advantage of it. Thank you very much and enjoy the conference.